2.2. Ready, set, go. The standard form of a quadratic equation is defined as y equals ax squared plus bx plus c, as long as a doesn't equal 0. Think about that. Here's an example. Given given 4x squared plus 7x minus 6. Okay, let's talk about this 4. This is a coefficient of x squared. Coefficient comes from the words co, which means with, and efficient, which means to work well. They are coefficient, they're working well together. You have the x squared quantity, like you put in a variable x, you square it, but then you also quadruple it. It's working together. They're working together. This 4 is a special number. Because it's working with an x squared quantity, we give it the name a. So a equals 4. 7's doing some work too, but it's working with a single powered x. It's the coefficient of x. We call it b. Very creative, very creative. B equals 7. And lastly, the constant term, technically a coefficient of x to the 0 power, which is just 1, so it's just, there's no x really, is minus 6. So c is negative 6. Let's look at this one over here. C is missing. That means it's 0. A can never be 0 and still be quadratic. If a is 0, then you just have a line. You don't have a quadratic. One of them is missing. A, B, or C will be 0. And so on. You get the picture. Down here, you have to multiply first. So x times x, x squared. X times negative 4, negative 4x. Then say what a, b, and c are. Here you have to multiply and multiply and multiply and multiply and combine like terms. And then you can say what a, b, and c are. Here you need to write out 2 copies of x minus 3 and then multiply and multiply and multiply and multiply and combine like terms. Then say what a, b, and c are. Here, you do the same thing, but then you multiply in the negative sign. So if you set this up, it'll be something like negative oh, very good. This is high quality content right here. Very good. So you'll multiply all this out with the rainbows and combine like terms, and then multiply in the negativity. You can think of it as a negative 1 hanging out there that you need to distribute in later. That's one way to do it anyway. Then graph y equals x squared, the baby parabola, the parent function, the function from which all other quadratic functions are just translations of. Okay, then after you do, so you've done this before, it's fine, here we go. But do it anyway, because when you get down here, they're going to start asking you tricky questions. This symbol is the lowercase letter omega from the Greek alphabet. But it doesn't matter what the letter is. It's just some symbol. Find a value for this weird symbol such that the graph will have the specified number of x-intercepts. So you may recall, after you do this graph, you'll see one x-intercept. The parent function just touches the x-axis at the vertex at 0, 0. This little dinky graph is slightly off, obviously. But anyway, one intercept. But how could you move it so that it would have 2 x-intercepts? Or what would omega. What would omega need to be for there to be 2 x-intercepts? What would omega need to be so there are no x-axis intercepts? This is the x-axis, of course. Fun times. Then they flip the parabola over, opposite of whatever x squared is. Now all the outputs are going to be in the negative territory, opposite of where they were before. And now what does omega need to be for it to have 2 x-intercepts. Is it the same number? Oh yeah, by the way, it says find a value. So you just need to think of a number that will work, that will create the situation that'll have 2 x-intercepts. A value that'll create a situation where there's 1 x-intercept. Some value which will make the upside down parabola have no x-intercepts. And then we're graphing. Move it right, move it left or something, but not up and down. Move it right or left and up or down. Move it right or left and up or down, and stretch it up from the vertex by a factor of 2. Sounds like a good time. Yep, same story. Grow half as fast. Down here, AOS stands for axis of symmetry. Okay. Good luck. See you guys soon. That's my kitchen.